All right, you guys, question 8 is going to be like the one we just did, but just kind of backwards, or like question number 35. Oh, wait, we did it? No, we did. Oh, you're just working ahead. Yeah, you're working ahead. You can practice those other ones while you're doing that, though. It's like question 35. And let's do a practice problem. Let's do question 35, which is, it gives us 3 times the natural log of x plus 1/2 natural log of y minus natural log of z. So it wants us to put it back into only have one natural log symbol. So let's just take it one at a time. This one we can put as the exponent. So we have the natural log of x cubed. Same, but I'm just going to make it, instead of having it v to the 1/2 power, I'm just going to put the square root of y minus natural log of z. This addition means that they could be multiplied together. So we just have the natural log of x cubed times root y. And then the subtraction will just be a division sign, x cubed root y over z. And number 10, is that where we're at now? Nope. We just did number 8. Sorry, guys. Oh yeah, number 8. Now number 9. Oh, this is the graphing one. Maybe let's go back so that we can use this to graph it on. This is like the question in our practice problems 33. So if we were going to graph the log base 2 of x plus 4 plus 1, okay, you can, in your calculator, graph this, and you could make your points. Base 2, you find under math, I believe. It's math A. If you do math A, you can find your bases. Okay, and you can pick a couple points and you can go ahead and graph it. The important part here are finding the asymptote and the domain. So what's going to happen is, we know that you are never going to be able to have an exponent that will give you a 0 answer. So what we want to do is figure out, where is x plus 4 going to be greater than 0? So if you subtract 4 from both sides, we know x must be greater than 4. Negative 4, sorry. And that's our domain. X must be greater than negative 4. And when you graph it, you realize that that's kind of what it looks like. Okay? If x has to be greater than negative 4 but not equal to negative 4, well, first of all, you can write it like this. Negative 4 to infinity. I'll take either way you write it. The asymptote is that x equals negative 4. Since x will never be negative 4, that is also the asymptote for that. Okay, so the important part is being able to utilize what is in your parentheses for log to figure out what will make what's in there always be greater than 0. Okay, it's never going to be 0 or less than 0. And I think there were some practice problems like that in your web work also, but we can answer some questions before the test if you need to. Solve the exponential equations. There is quite a few of those. Questions 19 through like 23. Questions 19 through 23 in your practice problems. And let's just do a couple of those. All right, so 19 says 9 to the power of x plus 2 is equal to 3 to the power of 3x plus 2. If I can make them the same base, then I can just set the exponents equal to each other. So 9 is the same as 3 squared. So then I could just multiply that times the x plus 2. That was the original exponent. Remember the power to a power, you multiply them, is equal to 3 to the 3x plus 2. Now we have the same base, so I can say 2 times x plus 2 equals 3x plus 2. Distribute my 2 equals 3x plus 2. Combine my like terms. So I'm going to subtract 2 x's, and then I'm going to subtract 2, doing 2 steps at once here. So I get 2 is equal to x. Okay. And you can always put that back in the calculator and check that you get the same answer if you make x 2. What that means is that 9 to the power of 4 is going to be equal to 3 to the power of 8. Okay. And how about we do well, let's just do a couple more for practice. 20 says 3 to the power of 3x minus 6 is equal to, and I'm going to make this 3 to the negative 2 power, because 1 over 9 is the same as 1 over 3 squared, which is equal to 3 to the negative 2 power. So now I have base 3. I can say 3x minus 6 is equal to negative 2. Go ahead and solve from there. Add 6 to both sides. Divide by 3. I don't think you need me to do that part of it. What about having to solve using logarithms? So we have 5 to the power of x equals 13. If we take the log of both sides, we're going to have x. This x comes down in front, and we'll take the log of 5 is equal to what you do to one side, you have to do to the other. So we're basically just taking the log in order to get that x out of the exponent. Now to get x by itself, I'm going to just divide both sides by the log of 5. So your answer, if you put into your calculator the log of 13, I'm having my little assistant do this, log of 13 divided by the log of 5. And probably it's going to have to be an approximately 1.269. And 22, 5e to the 2x equals 15. First things first, let's get rid of everything before we have to start doing logs. If we just divide both sides by 5, we get e to the 2x equals 3. And now let's just take the natural log of both sides. Since we're dealing with base e, we're going to deal with natural log. So, and actually, in this case is a little bit different. I'm going to take the natural log of e to the power of 2x is equal to the natural log of 3. And the reason I didn't bring this down in front is because the natural log of e is going to cancel. I'm just going to have 2x is equal to the natural log of 3. So x is going to be natural log of 3 divided by 2. Which I guess you could just leave it like that. There's no reason why you should have to divide it out. So let's just practice leaving it like that. Doesn't say we need to do anything else. Natural log of 2. 3 might die. I might not be able to finish these time at home. Oh, are we recording? Sorry, guys. I just did want to do that last question before I end this video, and then my battery's going to die. I'm going to have to go home and re-pick it up. But if we go back to the drawing board, literally, and do 3 to the power of x plus 3 is equal 4 to the power of x. If I take the log of both sides to bring these exponents down, I'm going to have x plus 3 times log 3 equals x times log 4. Then if I divide both sides by x and then divide both sides by log of 3 to get everything on the same side, I'm going to have x plus 3 over x is equal to the log, oh, very low. Let's see if we can finish this. The log of 4 divided by log of 3. So this is just a number. But to get x by itself, actually I should have kept this. Let's keep this x on the other side. So that's just a number times x. And then I'm actually going to subtract x. So we get 3 is equal to the log of 4 over the log of 3 times x minus x. Oh, look, did that smear? That's cool. So 3 is equal to, and if you put this into the calculator, what is the log of 4 divided by the log of 3? 0.62, and we're going to subtract 1 from that, so we actually get a negative. Oh, no, I got 1.26. Oh, I think you put in some things. Oh. So I got 1. This is approximately 1.26. So if I just subtract 1, I'm going to get a positive approximately 0.26. X, divide both sides by 0.26. And you get approximately 11.54.